Hi Steph, I'm afraid I don't have the webcam with me, but hopefully this still works and you'll still be able to hear me and see me drawing. Alright, so to help you answer your questions, here, range, remember, is the possible values that the y can take. So looking at a sine graph, the range is essentially the distance from there to there, or how far can it go between. Now, an ordinary sine graph goes between 1 and -1. However, this number here at the front is meaning that's going to be multiplied by 4. So really, here we're going to go between -4 and +4. So our range is between -4 and +4 inclusive, because we're going to touch at both ends. And that would be the answer. You can write that in a sentence or whatever maths notation you feel comfortable with for the there. Alright, state the range, amplitude, and period of this function. Alright, range is very much related to the first. Here, there's a -4 on the front of it. However, it's worth looking at this on the end. So, if we draw it out here, with that being the x equals 0 line, so the axis, this +2 on the end is the primary axis, meaning everything's been translated up by 2. So really, our sine curve, instead of going around the x-axis nice and evenly, is going to go nice and evenly around the y equals 2 line. And it's going to go around with an amplitude of 4. So really, this will start here and go, because it's negative, will go down to start, and then up. And it will go 4 down, so to -2, and 4 up, which will be to 6. So the range is everything from -2 up to and including 6. And you'd have to write that more mathematically than I have. The amplitude is the distance between the midline and the nadir, or the bottom, or the midline and the top. So the amplitude here is 4. Period is how often this repeats. Now, here, this would normally repeat, say starting there, coming back down there. Normally, one repetition would take 2 pi. However, here, the key is spotting this 3x there. So that 3x means it's happening 3 times as quickly. So rather than being multiplied, rather than when x reaches 2 pi, this repeats, here it's when 3x reaches 2 pi, this repeats. Therefore, x is equal to 2 pi on 3. So this will repeat every 2 pi on 3 times. So that then becomes our period. The other way to remember this is that the period is always equal to 2 pi on b, where b is the 3 there. And that's probably a good formula just to know. And I think next week I'm going to give you a printout of the Year 11 textbook, part of the Year 11 textbook, to remind you of some of these formulas. Alright, here, I'm not sure which question you're asking, but I'll do all of them. Alright, first of all, I thought you'd covered general solution in Year 11. You hadn't, so that's what Mr. Crawley and I are going to do with you this week, at the start of this week. However, I will show it to you here as well. Alright, tan of 2x is equal to pi root 3. So we can go to our magic table here and look at, well, tan of something is equal to root 3. What might that something be? Well, tan of pi on 3 is equal to root 3. So what we're saying here is that if we want to find a solution for this, this portion here must be equal to pi on 3. Therefore, 2x is equal to pi on 3. If we divide both sides by 2, x is equal to pi on 6. However, and that would be the first specific solution. However, it's not the general solution. So the general solution comes from thinking about the unit circle and thinking about, well, if the first solution is up here at pi on 3, With tan, there is another solution down here. And we'll get there by adding pi. And we'll get to the next one by adding pi. Sorry, pi gets us to there. And we'll get to the next one by adding pi plus pi. Or pi, another solution, pi, another solution. Essentially, as we add on whole number amounts of pi, each time we're going to get another solution. So what we could do, if we wanted to, is list all of these out. 4 pi on 3 is another lot of pi. And if we add another lot of pi on, it goes 7 pi on 3. And then 10 pi on 3, etc, etc, etc. However, rather than writing it out infinitely like that, we want to do this slightly more mathematically. We want to add on k lots of pi, where k is a member of the whole numbers. So this here looks a bit like a backward 3, just means is a member of. Z stands for integers in maths, or whole numbers. So our solution is 2x equals pi on 3 plus k pi, where k is a whole number. So we add or take off a whole number of pi, and we'll always get back to a solution. Then when we divide both sides by 2, we have to do the same to this portion here. So that's plus k on 2, or k pi on 2. So that where k is a member of the integers. And this portion here doesn't get divided by 2, because it's just telling us the properties of k, it's not part of the formula. This here is the general solution. If you gave this portion here, that would just be the first specific solution. Alright. The equation 2 sine x plus 1 equals b, where b is a positive real number, has one solution in this interval. Alright. So for sine almost always has two solutions. Because if you think about there being a solution of sine, well, there's the same level over there. Here, there's the same level over there, etc. So what it's saying is here, there's only one solution. So there's only one solution occurs at 2 points, here and here. Furthermore, you're told it's a positive real number, so it must be this solution here. So for this to occur once only, that must be 1. Alright, so where b is a positive real number, well, b must be 1. So let's solve for this. If b is 1, we take 1 from both sides and we get 2 sine x equals, find the value of b. We don't have to solve it, find the value of b. Read the question, it's just there. Actually, sorry, I've just stopped and had a think about that question. The logic's right with what I was doing, but I just did it a little early. Let's rearrange to get sine by itself first. So to get sine by itself, you have sine 2 sine x equals b take 1, then divide by 2. Sine x equals b take 1 on 2. Now for that to only have one solution, one positive solution, we're thinking up here. And we needed to get sine x on its own before we could think about it in terms of ordinary unit circle. So sine x on its own will only have one solution, and that's where this side is 1 high. So when this here is equal to 1. And b take 1 on 2 is equal to 1 when b is equal to 3. So our solution is b equals 3. Alright, if sine x equals minus 1, the value of x is 3 pi on 2. So, circle here, sine x is minus 1 occurs down here, that is 3 pi on 2 around. Alright, down. The smallest positive value for x, which the graph touches the x-axis. Alright, it touches the x-axis when f of x is equal to 0, or y is equal to 0. because y and f of x in our minds are interchangeable. So that's equal to 0 at 2 cos 2x plus 2. Alright, let's subtract 2 and then divide by 2, which leaves minus 1 equals cos 2x. So cos is minus 1 here, and that is pi around. So what we're saying here is that cos of pi equals minus 1, therefore this here must be equal to pi. 2x equals pi, x equals pi on 2. Which I really hope is a solution. There we go. Alright, I hope that helped. Do feel free to send more questions if you keep getting stuck. Thank you very much.